So I'm Nick Furness. I am going to talk to you over the next few minutes about how to make your iOS apps zing a little bit more with some animations. I'm going to talk not about UI animation particularly, I'm going to talk about animating within the context of the map. So here's what we're going to cover. If you came to this session last year, it's pretty similar, but the source code has been updated a little bit, and there's a few other bits and pieces thrown in, some special surprises. So I think it's still worth sticking around. We're going to cover point animation, polyline animation, and viewpoint animation. So has everyone here already worked with the runtime version 100? Familiar with all these viewpoint concepts and the like? Great. Well, we'll dive right in to a demo. So here we're looking at a route that's been generated, and if I tap this button here, we're just going to move a dot along it, right? So you'll notice a couple of things. First of all, it's moving along the route, but secondly, it's also maintaining its orientation to be aligned with the route. So let's take a look and understand exactly what's going on here, break it down a little bit, and talk about what's happening behind the scenes. So really simply, all that happened there was we were animating along a line from start to finish, and an animation is really just a sequence of positions over time. So we have the start of the animation time, the end of the animation time, and the question we're asking all the time is, hey, I'm now halfway through that time, so where should I put the dot right now? And we do that at 60 frames a second until we reach the end of the line. That's the animation that we just saw. To do that, we've built a really simple helper class, animate along path. It takes a polyline. In this case, it was the result of a route task. It takes the animating graphic. Now that's the little black diamond that we saw. So that's the graphic that we're going to animate along the polyline, and we take a speed as well. So between these things, we know where we're going to animate and what we're going to animate. We have a start animation and a stop animation method on it. Now calling it, well, before we jump into calling it, there's also a delegate that gets called at the end of the animation that lets you, the caller, know, hey, this animation's finished, you can get on with whatever you were waiting for that animation to get you to. This is how you call it. Animate along path helper has a constructor. You pass in a polyline, the car graphic, which in this case had probably already been added to a map, and a speed. And then we just start animation on it. So what happens inside that start animation method? Well, it's really straightforward, honestly. We get the length of the polyline, we figure out how long we want the animation to last, the length divided by the speed, and we keep track of the start time. Given that information, every time we call into some code 60 times a second, we can figure out how far we are from that start time towards the end of the duration and work out what we need to work out. So here we're calling a method on something called Animation Manager, which I'll talk about in a second, called animate. And all we do is we pass in a block. That block gets called 60 times a second, and we just figure out a couple of things. First of all, we do some good Swifty sanity checking to make sure that we're going to be working with things that are sensible, but the real guts of it lives right here, where we figure out what I've just called the done factor here. It's like, for the time right now given by that date constructor, how does that compare to the time we started this animation, and how does that compare within the context of the entire duration of the animation? Given that factor, give me a point, a distance along the polyline that we're following. And then all I need to do is take that animating graphic and update its geometry. The runtime takes care of everything else. It takes care of refreshing the map, of moving the geometry, of moving the graphic. So let's take a quick look at the animation manager. This is, again, a really simple class. It has a timer it keeps internally, and an animate method. The animate method we saw being called with that closure, that block. That block's purpose is to update the frame for the current position, for the position in time along that animation duration. And there's a pause and a resume method, and there's a bunch of other stuff as well on there that you'd expect on something that manages animations. This is a singleton, so anything that needs animating within the map, within your application, can call into this animation manager and just pass a block and animate something based off that block. We'll look at an example of multiple ones working together later. It's got that internal timer that I mentioned that fires 60 times a second, and it keeps an array of closures. So everyone who requests an animation, their closure is going to be held onto until the animation's finished, at which point we remove that from the array and the timer no longer does anything. In fact, when the array is empty, the timer shuts down so that we're not even spinning anything there. So let's take a look at a couple of other examples of this in action. First one I want to show is this. So here, is that me or them? I'm simulating some cars moving around. And we can see this is a fully interactive map. These cars are all just pootling along happily. In this case, they happen to be following paths that I've generated, right? But what they could be, you could be getting sporadic GPS information back from a fleet. And rather than just making that car suddenly appear somewhere else, it's better experience for your user to see that car animate along. You see that in the Uber app, right? When the car has been stuck 3 minutes away and all of a sudden it's on your doorstep and you're about to be late and fined for it. But at least it animates while it's telling you that. But again, all of this is happening independent of how well the map performs. Let's also jump in and take a look at some aircraft flying around. So here we've got another example. And you can see here something you take for granted. I mean, first of all, it's very responsive, 60 frames a second, we can interact with the map. But also, just bear in mind, you take it for granted, but these aircraft are pointing in the direction they're going. Usually when you want a point symbol on a map, like a street sign or a museum label or something, you want that always to remain upright, no matter what orientation you rotate the map to. In this case, it's important that these symbols rotate with the map, and the runtime makes it very easy to do that as well. It's just a simple switch. It's a setting on the symbol definition. So let's change tack very quickly and go back to something that looks a lot like the very first demo, but this time, instead of a dot following the line, we're going to trace out the line. So this is another approach to animating stuff on your map, and you see this in the Uber app as well, for example, a bunch of apps, giving some context to the line that you're about to put on the map. Now we took about 15 seconds, maybe you want to take a second or two to do that. So we'll jump back to the slides and talk about that very briefly as well. We'll bounce through that and get right into Polyline Animation. So from before, we showed how animating a dot along the line is a progress through time. Well, when you're tracing out a line like this, it's exactly the same thing. Instead of moving a dot along, all we're doing is we're building out the line to that next point. And that's very easy to do with the Polyline builder in the runtime, and we'll see how that works in the code in a second. So I created an animate line trace helper class. Again, this is really simple. It takes the polyline that you want to trace, you give it a graphic that you've put on the map, but it doesn't actually have a geometry yet. That geometry over time will grow from nothing to the full length of the traced line. And the runtime will take care of just refreshing that as you update the animate graphics geometry. And a speed indicates how fast we want to get through this. Start animation, stop animation. So it looks identical to the previous thing. In fact, it really is. We look at how the start animation works in here. Again, we're doing the same preamble. We're figuring out the length, the duration, the start time. Then we're asking the animation manager to animate this block for me 60 times a second. Even within the block, we're doing really the same stuff as we did before. We're getting that done factor and we're getting that new location along the source polyline. Only this time, instead of updating a point graphic, we're extending a polyline builder to that next point. And all we do then is we take that polyline builder dot to geometry, which is a polyline, and we set that on the animating graphic. And lo and behold, over time, that animating graphic just grows and grows and grows until we had that finish event that happens at the end of the animation. So let's take a quick look at that in action as well. We jump back to the iPad. Very similar animation to before. Only this time, instead of seeing the planes, we're going to see their flight paths grow over time. And actually, I'm going to jump out and jump back in again and show the combination of the two. And again, fully interactive, very, very responsive, nice and fast. Easily done, just with a few lines of code and that animation helper. And remember, the bulk of that animation was just done with a single call to the AGS geometry engine, point a long path at distance. We just had to calculate what the path, give it the path and calculate what that distance actually was. So I'm going to change tack a little bit now and talk about actual viewpoint animation. So we looked at animating things in the map. Now let's look at animating the map itself. So you're probably all familiar with setting a scale and zooming in on the map. What we also have are some methods that give you the ability to zoom smoothly, chain pan operations together, chain viewpoint operations together. And we'll jump back into the slides and take a look at what that actually means. So in this case, I'm not talking about custom code that I've written. I'm talking about stuff that's just built into the runtime SDK. So we have the AGS viewpoint. It's our way of telling the map view what we're interested in seeing in the map view. We can create a viewpoint with a center point and scale. We can add some rotation. There's a few different ways of creating this viewpoint, which we can then just set on the map view. And the map view will just blitz itself over to that point, and that will be the new view of the map. There won't be any animation involved if you just set viewpoint. But there are methods on the map view, set viewpoint methods, that have a completion. If you see a completion parameter on the set viewpoint method, it means it's going to animate. It means it's an asynchronous thing. It's going to take some time. When it finishes that animation, it's going to call into that completion block so that you can do something if you're waiting for that animation to finish. And what we saw in the demo just there was a smooth animation in, and in the completion block of that animate in, we then immediately animated back out again. So it gave the map kind of a little breathe experience kind of thing. It's a convoluted example, but it shows how you can change these things together and how the completion block is important to you. In addition to just doing a linear animation, the runtime actually has a bunch of different animation curves you can use. So if you want to start off slow, then speed up, and then slow down at the end of the animation, that's encompassed in the set viewpoint methods that include a curve. There are a few other convenience methods on map view so that you don't actually have to create a viewpoint before calling set viewpoint. So you can just animate to a center point, or set the scale in a center point, or rotation, change the rotation only, or jump to a geometry. With a completion method, that's going to be an animated thing, of course. So all of these convenience methods will help out. So let's jump into another demo and see that in action. Here we're going to go and look at some turn-by-turn directions that we got back. So again, looking at the same route, only this time we're actually going to see the turn-by-turn directions behind it. So here, step by step, we're following through the route, and we're actually rotating the map, recentering and rotating the map in an animated way to give you the context of where this next turn is. So we're generating this little line around the corner of the map, and we've got an arrowhead on the front of it. So that's all included in the styling in the new runtime SDK. And we're able to just do animation there to give you a little more context and a little more flow to your application rather than just jumping you to the next location. So, brief summary, we've seen moving a point along a line, and we saw tracing a line, and we saw how that was actually the same thing. We're just doing a slightly different thing with the output of the animation. We also saw animating the map's viewpoint. Some tips for you if you're going to be doing animation. So graphics overlays and feature layers have a couple of rendering modes. They have static rendering mode and dynamic rendering mode. As the name dynamic implies, if things are going to be moving a lot, and you got a lot of things changing, moving in the graphics overlay, set its rendering mode to dynamic. That'll help you out a lot. Use a renderer as well. So in a graphics overlay, you can create a graphic, and that graphic can include a symbol. If you're adding lots and lots of graphics on there, each with their own symbol, it's more efficient by far to set a renderer with a single symbol, and the internals of the runtime can optimize that much better for rendering all these graphics. And that's what these samples were doing there. I mentioned the animation manager keeps just one timer. Another approach is to say, well, each animation should have its own timer and be completely independent. Start, stop, manage its own timer. You can get stuck if you create too many timers in an environment like iOS. I mean, for the examples we saw, probably won't make a difference. If you're starting to animate thousands of things, you might find yourself in trouble. And having a consolidated approach that manages the number of timers that are running these things is really useful. If you're dealing with complex geometries, try generalizing them. It'll help with rendering. Obviously, don't generalize beyond what you need to see. And also, everything I did there was really done with very simple geometry engine calls. I'll make the code available. There'll be a GitHub link coming up here in a second. And when you dig into that, you can see, for example, the rotation stuff, figuring out the headings and the angles. That's all done with a single line of geometry engine, as was actually the point along path. From a UX perspective, I talked about showing direction to add a little bit of context to your animations if it's appropriate. And also, don't go too crazy with animations. It can be a distraction. I'm about to break that rule. I'm going to show one more demo here. And this demo may take a couple of attempts to get started. It's kind of a work in progress. But bear with me. Nope. That's better. Okay, so this looks a lot like the flight path demo that we saw. Only this time, as we zoom in, we see actual aircraft, and this is in 3D. So this is a full three-dimensional scene. That's kind of okay, right? I mean, it's sort of interesting. If I tap on the map, we zoom in and we follow a plane. What I want to highlight here is I'm not actually following the plane myself. I've told the runtime I want a camera view on this graphic. I'm animating the graphic's position. The runtime is taking care of animating the camera to follow it. In addition to that, I can spin the camera around. That happens with another runtime call. So the runtime has a method on it that will animate the camera around the geo element that it's looking at. My interaction with the map here as I pinch and zoom and pan around is now glued to this plane. And by doing these things in combination, I mean, this is kind of like staring at the seat in front of you on a 16-hour flight to Hong Kong, or maybe a little more dizzying. So, careful with your animations. But I can tap on here, we can jump to another plane. You can see the animation stutter very slightly as it's loading some tiles, but it does catch up. And we can zoom right out and try and get some context on how that fits into everything else. I'll jump back to the slides and just show the APIs that I was talking about there. So here we've got this orbit geo-element camera controller. You set the scene to use that orbit geo-element camera controller and pass it a geo-element. In my case, I gave it the graphic that was the plane that happened to have a 3D object model as its symbol. And then whenever I tapped that spin me right round button, the camera I called that move camera with distance delta, heading delta stuff. I said, I want to spin around 270 degrees and I want to be further away from it. Then when that completion handler happened, I spun back in again a couple of times around it and went back to where I was distance-wise. So that's what I've got for you. If you can go to the Events app, find this session, scroll to the bottom, fill in the survey, I'd really appreciate it. The code for this is all available here. I'll leave this slide up. That's all I've got for you, so thank you very much, and we've got plenty of time for questions. Once you've all taken photos. Yes? I'm worried that this is going to feed back. Did that happen with you and Sandy? Back out of range of the speakers. So the question was, in the turn-by-turn directions demo, where the map rotated to show the arrow pointing upwards, was that handled by the runtime, or did I have to do that? I had to calculate that. So I look at the first point of that line, I look at the next point of that line, and that gives me the heading. And I just use that to animate the rotation of the viewpoint to that heading. Yep. Yes, the first sample I did the same thing. So where the arrow rotates as it's following the line, yes. So I'm looking at each step of the rotation, and that's actually built into the animation helper that I built. So it's looking at the polyline it's built. It's actually looking at the point and the previous point in that case. I'm getting a heading from that and setting the orientation of the symbol. So the orientation of the symbol can be done in one of two ways. You can either the marker symbol itself has a rotation property on it, or if you set up a renderer on the graphics overlay, you can set a rotation expression on that renderer, and it will interrogate the attributes of that graphic to look at that rotation expression. So in the animation handler, we're actually updating an attribute on each graphic in there. In the case of that single sample, that's just the one graphic. In the case of all the cars driving around San Diego, each one was updated with the heading. And then the renderer takes care of manipulating the direction that it's facing in. So the question was, and we should get, yeah, we should talk about it afterwards. But the gist of the question was, if I have a large amount of GPS data as a track, can I animate that into the map? Yes, absolutely. I mean, the runtime will handle a lot of data, but we should get together and figure out the best way to do that and exactly what the experience is that you're looking for. Because if you're just looking to highlight occasional points, so you have a GPS track and then 30 minutes, 45 minutes, an hour, and you just want to highlight some things, that's one thing. If you want to actually track it over time and have a slider, perhaps you scrub back and forth, that's another thing. But let's talk afterwards and figure out exactly what you want. Yeah. Are there any pin drop animations? Not this year, but I've already talked about doing that. I want to extend this demo with that. Eli here actually is working on an example app that includes a pin drop animation. Our approach there was to use UI view and animate the UI view above the map. So you can take a swatch of the graphic that you want to render, drop it into a UI image view and animate that. So that's about right? With core animation, yeah. Right, but my next step is to investigate actually doing that with graphics. What we saw there was a linear animation, right? So the only thing that's stopping me from doing that is building a little engine that allows me to use arbitrary curves for the animation rather than a linear thing. The animation helper, animation block stuff is going to work. I mean, it animates until it's finished, right? So it's just a question of determining the path through time and then the finish point.
Even this on iOS, did you use any special?
Question is, I did this in iOS, did I use any special functionality that's not available in any of the other runtime SDKs like Qt? No. I'm basing it off an iOS timer object. That's it. Yeah, everything else is consistent across the other runtime SDKs. Any more questions?
Is that performance, is it like memory intensive or is it like performance intensive on the app in terms of battery or usage so many animations?
Okay.
Have you done any testing?
Yeah. You kind of answered your own question there. So the question was, are there any performance impacts of this, particularly in terms of battery consumption of doing these animations? And have I done any testing? And the answer is I haven't done any testing, and so that might inform the rest of the answer, which is that I actually don't know. I don't think for the stuff that I was showing there, I can't imagine there'd be a lot. But you're absolutely right, it's worth looking at, it's worth stress testing and seeing what the impact is. All right. Good stuff. There's another interesting session coming up right after this, I think, on task patterns, load patterns, and the like. So stick around if you want to learn about that. Otherwise, I think I'll be at the island tomorrow some of the time. No, I won't. I'm flying back tomorrow. But I'll hang around at the island for a little bit if you have more questions. We'll talk to you later. Thanks a lot.